I bought these things. So in order to mount this stuff in the ceiling, I took all of this and put it into this PCB. No idea if this will actually work. Yeah, let's see what happens. Okay, nothing burns, that's good. 5 volt here, yes, and 3.3 volt here, yes. So, what's the next thing? The next thing is we need our firmware here. So let's flash WLED. Okay, so let's connect it to the computer. Ground goes to ground. RX, so receive. And receive usually needs to be connected to transmit. Transmit. And of course everything that is transmitted here needs to be received here. Receive. And then I have the reset. There's actually no reset on this one. I guess we will have to manually reset it. That thing gets hot, that's not good. It gets very hot. Very hot is very bad. So it turns out I made a mistake. ESP32 has this boot pin. And boot pin is GPIO 0 and I actually connected it to GPIO 2. This will be fixed with a little wire. I connected the GPIO 0 to GPIO 2 and GPIO 2 has a pull-up resistor and I need to connect it to ground in order to get into the bootloader. Next thing is I will flash WLED. I will use Google Chrome and go to install.wled.me and then press install. Select the converter, then press connect. And then install. Yeah, it may be required to reset it, but in this case it just worked just fine because it started into the bootloader mode. All we need to do is just wait. And the installation is complete. Next, if everything worked, it should open up a new wireless LAN. But in order to boot into the real firmware, we need to remove this stuff right here. I will remove ground from GPIO 2 and also this bridge. We don't need this bridge anymore. Ha! Other networks. Here it is. Okay. So it should create this access point. Yeah. Which password? Okay. WLED 1, 2, 3, 4, 5. You'll see this menu here and go to the controls. Let's see if it works. Yeah, it should be turned on already, but I don't see anything. However, we use a relay GPIO and that is 12 and it's not inverted. Safe. Still no voltage here. Now it's turned on. That's exactly how it shouldn't be. This is actually wrong, but okay. Like, go to the controls. Yeah, now it works. So I can control the color. As you see, if I select red, it's green. If I select blue, it's blue, and green is mixture. So there is something still wrong. So they have not only RGB but also a white LED. So we need to select this. Yeah, it's a RGB plus white. RGB plus white. And now everything works. We have red, we have blue, we have green, and we also have white. Very nice, very nice. And this is our white channel. So this is just white. And this is our RGB channel. And we can mix them very nicely. Awesome. Now one last test before it goes into the ceiling is, of course, the full length. Let's power it on. Now as you can see, some of the LEDs are not turned on. Why? Because inside of the settings you need to select how long it actually is. Right here I have length. In my case it's more than 30. Don't know exactly how many, but I would say maybe they are 100. Yeah, looks like everything is light up. Now we can do some cool effects. Pretty crazy. I would say everything so far looks pretty nice. I will produce more of them and put it into the ceiling. New problem. The ESP32 is consuming a lot of current, and that means that the LDO heats up extremely. The LDO takes 24 volts and then converts it into 5 volts. What happens to the difference? The difference is heat. This heat is power equals voltage times current. The voltage difference is 19 volt and the current is 130 milliamps. That's what I measured. So we have a power of 19 times 0.14, 2.66 watts on this SMD package. Not great, but I have a solution. This is the solution. This is a DC converter. It is way more efficient, so we have an efficiency of around, I would say 80% maybe. And I just looked it up, it is actually 86. It's 86, yeah. So it makes it even better. 0.11 watts versus 2.66 watts. So this is the big difference, yeah. And this is why I hope that it will cool down. Certainly will. It's a completely different footprint, so yeah, this will be funny. I don't have hot air and I can't really put it back into the oven, so I will destroy the component and put this thing on top. Yeah, I can try to remove it. I will try to remove it. Don't want to destroy it. Don't really want to. But I am not very confident because it has this huge ground plane underneath. It has heat traps, so maybe I'm lucky. Some of you may ask, it is working, why do I replace the LDO with the DC-DC converter? Well, it's working at the moment, but I don't want 100 degrees in my ceiling, right? I don't want it to burn down my house. It's not what I want. All right. Okay, let's heat it up. Unbelievable. Okay. It's out. So this is in, this is ground, this is out. Beautiful. Not. And this is what it looks like. We now have around 50 degrees Celsius. That's way better. That is something that I will put in my ceiling. And the ESP is very dark. This is actually wrong because it has this metal shield that is reflecting infrared. That's why it looks like this. And you can see the LEDs heating up, but not too much, just 30 degrees, 31 degrees Celsius. Very nice. Okay, as you can see, the LEDs are working already. Let me show you the WLED web interface. So I can press the sync button to sync all my LEDs. And everything I change right now will affect all of my LEDs. So if I make it green, all of them will turn green. If I select an effect like Android, all of them will get the same effect at the same time, which is very nice. And one last thing, I also integrated it into the shower. I really enjoyed this project. If you liked it too, please give it a thumbs up and subscribe to the channel if you want to see more projects like this one. See you in the next video.